Hi everyone, welcome back to the channel. So if you see how IIT JEE has been asking questions from last 10 years, 20 years or even 30 years or before, is that they mix different areas to form a question. It is necessary to test the concepts of the student who are appearing for the examinations. So they will mix a question, let's say, involving SHM and also electrostatics, or let's say they can use thermodynamics and angular momentum and something like that. And then it forces students to think little differently and then come up with the solution or answer. So here in this channel, my job is to come up with some of the questions which are going to be very likely for JEE, and also something that can give you some experience, some insights and some concepts to tackle such questions. Okay, so this question is no different. So let's read out the problem. Two conducting plates are a distance d apart. So these are the plates here, and the PD, the potential difference between the plates, is V. Okay, a particle of mass m carrying a positive charge. So let's say this is the particle at this t equal to 0 is this particle is here, and the charge is q, is released from rest. So initially it has zero velocity. Due to the uniform magnetic field of induction B acting at right angles to the electric field between the plates, the positive charge is prevented from reaching the negative plate. So we need to find the minimum value of B such that this is possible. Okay, I hope the question is clear. So let's see how to solve this problem. Okay, so first define the coordinate system. So let's say this is X and this is Y. Okay, and so B is acting in Z direction because this is out of the paper. And let's say at any point P, let's call this point P here. Okay, and its velocity is like this, let's say. So the first question is, why would there be a velocity for this particle, right? You see that since the plates are positively and negatively charged, so there is an electric force here in the positive y direction, right? You see that the E is acting in y direction, and because of E and there is a positive charge q here, so there will be force that will be always acting in this direction, which is going to be QE, right? You see this? Now, there is a B which is out of the paper. So as it starts moving, let's say it acquires initially the velocity in this direction in positive y, but the moment it acquires a velocity in this direction, there'll be a force which will act immediately at this point in this direction using Lorentz force, right? So we can use the Lorentz force, and it says that the F vector is equal to Q E plus V cross B, right? Where E is electric force, V is velocity, and B is the magnetic force vector, right? So QE here, let's just write in terms of I and J. Let's say this is I and this is J and this is K. So we can write F as Q E J plus V at any time. Let's say at point P, let's say the velocity, let's just write it like V into B, and B is always in the K direction, right? Okay, now let's define V as Vxi plus Vyj. So we know that the velocity of this particular particle will be in xy plane. So at any time t, so let's say this is at any time t equal to t, right, at point P. So at point P, which is xy, let's say, and the velocity of the particle is Vx in the I direction and Vy in the J direction. So if we use this, then the Lorentz force can be written as Q Ej plus Vxi plus Vyj cross Bk, right? Let's further expand this. So this is Q Ej plus Vxi into K. What is I into K? I into K is nothing but minus J. So minus Vx Bj plus Vy J into Bk. So J into K is simply I. So Vy Bi, right? So let's club the J together. So E minus Vxb J plus Vybi. So this is the force, total force that's acting on the particle at any time, right? Let's analyze this force. So you see that there is a force Vyb in the direction of I. So there is a force here, right? Which is Vyb. And there is a force here which is QE minus Vxb, right? This is the total force here in the y direction. So this is Vyb, and then there is QE minus Vxb, right? This is Q, right? So as the Vx is increasing, this force will keep decreasing, right? And the Vy will keep increasing. So eventually what will happen, that if B is not large enough, then this particle will not be able to reach to this plate. And that's the question, what should be the minimum B? Now let's see how to proceed further. So let's write the first X, force in the X direction, because we can also write F as Fxi plus Fyj. One thing you should note is that dealing with such problems where you have multidimensional forces, it might be a good idea to just use the vector, because then it reduces the focus on the worrying about the signs and directions and all that, because then you start dealing mechanically with ijk, right? So that's what we are doing. So let's write fx and fy. Now we can equate the I part. So fx is Vyb, right? So fx also means that m dvx by dt equal to, don't forget the q part here. So qb Vy, right? And fy is qe minus qb Vx, and dvy by dt is equal to qe minus qb Vx, right? Okay, let's just expand on this little bit. And if we see second equation, this equation, okay, what I want is basically to get the acceleration in the y direction, and in fact deceleration in a sense, because it is going to decrease, right? And then see how we can use that to perform some of the other calculation to find out the minimum B, right? So let's just double differentiate this, because so that we get the acceleration in y direction. So d2 Vy by dt square is, this one is 0 because q and e both are constant, and this will be qb dvx by dt. Now we already got the dvx by dt, so we can use this and write minus qb and then qb by m Vy, right? So I'm sure you will find this equation quite familiar. So if we write this d2 Vy by dt square minus qb by m whole square Vy, So what do you think? What does it resemble to, this equation? So this is just a SHM, equation of a SHM for Vy, right? So the velocity of y will be doing SHM, which means it will going up and then it will come down and then it will go up and then it will come down and it will keep doing that, right? Okay. So we can also write this as minus omega square Vy, and therefore omega is QB by M. So this is the frequency for the Vy SHM, right? The particle's velocity. So far so good. Let's form the equation of Vy because we know that it is going to do SHM. So we can write the equation as A, some constant, sine omega t. We already know omega. Why did I select sine omega t? Can you tell me? Okay, so think about it. At t equal to 0, Vy is 0. So we need to select sine omega t because it's simple enough. At t equal to 0, this Vy will be 0. Okay, that's why we are not selecting it, cos omega t. Okay, fine. So what is the dy by dt? dvy by dt? A omega cos omega t. So at time t equal to 0, dvy by dt is qe by m because vx is 0. And this is coming from this equation, right? This equation. Vy by dt is just qe by m because vx is 0, right? Therefore, a omega is qe by m. QE by m because at t equal to 0, this is 1 and hence a omega is QE by m. That implies a as QE by m omega, and we know that omega is simply QB by m from here. Therefore, we get a as m cancel, q cancel, so e by b. Okay, so we can write Vy equal to a sine omega t. That's what we assumed. Now a we know is e by b sine omega t, and therefore Vy is nothing but dy by dt, because all we needed was an expression for Vy so that we can compute the y, and the maximum height that it can gain is the distance between the two plates. Okay, so dy by dt equal to e by b sine omega t, because we computed the Vy. So to compute Vy, we had to compute the omega and then a, and using boundary condition we did that. Okay, so y, we can just integrate this sine omega t dt. Okay, fair enough. So that means y equal to e by b, and sine omega t is minus cos omega t, let's say 0 to t. So it will be minus cos omega t by omega. So omega will come here and then 0 to t. So which is e by b omega 1 minus cos omega t, right? So what is the maximum? What do you think is the maximum value of x? Okay, so now we got the expression of y. When do you think we will get y as y max? So y max. So this will happen when cos omega t is minus 1. That's when we get this as maximum, right? You can also do it using differentiating it and figuring out. So which means omega t is pi. It has to be pi, or you can say it is 2n plus 1 pi, right? For n 0, 1, 2 and all that, right? Okay, so for n equal to 0, we get omega t as pi, which means that t equal to pi by omega, or you can, in a general way, you can write 2n plus. So at this moment, the y will be maximum, okay, because it will keep going up and down and up and down like that, okay. So this will keep happening, right, between the plates. Okay. Now, so y max, we can write it as 2e by bw. So 2e by b, and we computed w somewhere. So w is qb by m, right? qb by m. So which is 2m e by qb square. Therefore, we can write y max as 2m v by d divided by qb square, E equal to v by d, right? Okay, potential is equal to E into d. Now we know that y max should be less than d if particle should not reach the other plate, right? Therefore, d must be greater than y max, equal to 2mv by qb square d, and therefore b square should be greater than 2mv by q d square, okay, and b should be greater than 2mv by qd square root under. Okay, so this is the expression for b, and b minimum is this one. That's the answer. Okay, so this is one way of solving this problem. Now let's try to solve this problem using different way. Okay, go over the method number 2. Okay, this one is a lot more simpler than the first one. The idea to give you the first method was to show you some of the things that can come into the picture for solving a problem. And that method is that if you see the two plates, right, then you will understand that the curve is going to be like this. And at this point in time, let's say there is a force in this direction, which is QE, and there is a force here in the negative j direction, which is q. Let's say the velocity at this point is u, so qub, and there is also going to be a centripetal force here, right? And these two things should be balanced. These forces should be balanced for this particle to be in this particular path. Now the only question is, what is the radius of curvature? Radius of curvature at, let's say, A. This point is, let's say, A. So the answer is 2D and not D. And I leave this as an exercise for you guys. So figure out why R is equal to 2D and not D. Okay. Let me know your thoughts in the comment and I will respond as soon as possible. Okay. So QUB minus QE should be greater than equal to MU square by 2D. Okay. Okay. We can just use, instead of E, we can use V by D, MU square by 2D. We are using this because V is given. The other important point is that we are calculating about the minimum B, right? So at this point, let's say we assume that the kinetic energy, gain in kinetic energy uses the entire the electrostatic energy. So we can write half MU square is QV. Let's say it uses the full QV. Okay, so which means that U square is 2QV by M, right? So from here, let's say 1 and 2. From 1 and 2, we can just write QUB minus QV by D should be greater than equal to 2QV by 2D, which is QV by D. Therefore, we have this case here where QUB is greater than equal to 2QV by, right? Or that means that UB is greater than 2V by D. And if you just take the U square, it is 4V square D square by B square. Okay. And U square is nothing but 2QV B, 2QV by M, which means 2QV by M is greater than 4V square by D square. B square. B square is greater than equal to 2VM by QD square, or B is greater than equal to 2VM by QD square root under. So we get the same equation here again, same expression for B, right? It should be 2VM by QD square root under at least, right? So this one is a lot more simpler, but you need to think through these things. Okay, that at this point you need to balance the centrifugal force, all the forces. You need to think about the radius of curvature, which is 2D, not D. Think about it and let me know. And then you need to also think that QV should be spent in gain of the kinetic energy for the particle. And once you do that, all these two equations, along with the 2D, the radius of curvature, you should get the expression. This one is little elaborate, but it is a lot more logical and it flows naturally as you go along. And it simply uses the Lorentz force and just uses this force and keep expanding on it, and then you will get the answer. Okay, so I hope you like this problem and you also like the solution. So please do subscribe to the channel, like this video and share this with your friends. Thank you very much. Thanks for watching. Subscribe and gain access to concepts and tips for doing better in IIT, JEE or other examinations. Keep up the great work.